Good afternoon, my name is Faisal Sahib. I'm from OmniPC in New Zealand. This afternoon I'm going to show you a short video on how to use OmniPC 5 to analyze a corrosion scan. So I already have OmniPC 5 open, and the data that I have here is of a corrosion encoded scan on an elbow using a FlexoForm. So on OmniPC 5, if you look at under groups and layouts, under layouts there's a drop down and you can select the format that you want. You can have the A scan, the C scan, or different combinations. So what I've selected for is the AC and S scan. So this is my A scan, sectoral scan, and the C scan. On the right hand vertical plane you see some data. This data relates to the two blue lines that you see on this C scan, which is the data cursors. So this is the scan data cursor, which is the vertical, and the horizontal is the index data cursor, which relates to the VPA as well, up the top here. Right. My area of interest in this scan is the red region here. So I'll just move these cursors out of the way so that I can start doing a bit of analysis. Right, so what I'm going to do, I'm going to use my referencing and measurement cursors to box this defect and zone it, so that within the zone we can determine what is the minimum thickness. So by right clicking on the mouse, I'll select reference cursors, which is red in color. So here it is, my red vertical and horizontal cursors. So what I want to do is have this cursor as close as possible to the defect. So I'll move it out a bit, right about there, it's fine. And for now I will leave the horizontal cursor where it is, but if you want to, you can fine tune it by taking it out a bit or putting it more in the red zone. Entirely on you how you want to use or do your analysis. Now I will right click on the mouse again and use my measurement cursors. In the green, horizontal and vertical are my measurement cursors, and I'm pretty happy with where they lie at the moment. So what I've done is I've used my reference and vertical cursors to box the defect and zone it. So on the right hand plane where you see data, it shows few different things here. So up the top is your amplitude percentage, then the next one down is your thickness between gate A and your interface gate, material loss, your scan distance or the distance between your reference and measurement cursors, this index distance between reference and measurement cursors, and then you have other bits here. Right, so T min Z is your thickness minimum in the zone. So this zone is this box that we've created. And then S T minimum Z is the scan position where the thickness is the minimum, and same where the index position where the thickness is the minimum. So to find the exact point over here on the scan where this is, we will use these two data positions to bring these data cursors onto the particular spot. So I will use the scan position of 13 up the top here. And the index position of 169 up the top. into index box. Once you've done that, the data cursor automatically drops into the minimum thickness point, which relates directly on the sectorial scan as well, as you can see. Right, so once I've done that, I will add this into the indication table for reporting purposes. So on the indication table, if I click on that, I have here number 3 because I've done previously number 1 and 2. So in here, if I select that, I have an extra action available where I can either delete it or just leave it as it is. So for now, I will leave it as it is. I will call it a reject and put a data saying minimum wall thickness at 1.8 millimeters. So this 1.8 millimeters is here, the minimum thickness in that zone, which relates to that position there, and that data is being stored. Right, moving forward. So there's another spot here that I need to further look into. So for now, I will turn the cursors off, drag this cursor slightly out of the way, and this is the area that I'm interested in. So I will use my zoom function, put the first point and zoom into the position. So here is the zoomed area. So using the same process where I will box the defect in and find the minimum thickness in that zone. So using my reference cursors, plot it in, almost perfect, and then my measurement cursors. I could drag this down a bit, but I'll leave it as it is for now. Right, so I'm on the data side of things now. My scan position has changed to 204, but my index is still the same, which it won't change. Because the scan position has changed because we've gone further along the scanned area to find the defect. Right, so same thing, I will put this value up the top here of 204. And the index will be the same. And there's my actual data position, which relates to the sectorial scan right here. Now, I'll add this into the index table again. And that will be my position 4. I'll say reject and call it lamination defect. And this time the position is 2.15 millimeters. And keep that there. Moving forward, click on report, and this will show you what your report looks like. And then from here, you can save it, you can generate a report and give it to your customer or file it. So page 1 of the report shows the instrumentation, the OmniScan type used with the serial number and the module. Then is the part and weld, which you set it up. Page 2 shows the area of scan, which you have collected the data of. Page 3 shows the probe characteristics, the probe type, etc. that was used, and then the setup. Page 4 then shows you the indication table and the values and the data that you've stored. And page 5 shows you the picture, and the pictures show the data positions as well, along with the numerical data values. So here it is. Hope you found this interesting and look forward to further videos. Thank you very much for your time.